So here we have a model of a 4-cylinder inline engine. How does this thing work, and how does the bottom half connect to the top half? For class, I have some parts of a real engine of a 1967. You can see this was cast in 1966, 289 cubic inch. So 289 cubic inches of volume for the combustion chambers of this engine. And this is a V8, all right, V8. So 2 sets of 1, 2, 3, 4 cylinders. You can even see the rings here where the cylinders went. So here's another model of an engine that's not quite assembled, and you can see the 4 combustion chambers, 1, 2, 3, 4, and you can even see those blue pistons in there. So for this part to work, what happens is we put a mixture of gas and oxygen in here and ignite it with a spark, and then that's going to push this down like that. Now maybe you noticed over here that when I push this down, that rotates, right? This is how we turn linear motion, up and down motion, into rotational motion, and then we can connect this through a transmission to the wheels, and the car goes, all right? So this is the bottom half of the engine. It's pretty simple. Now the top half is a little more complicated, and it's complicated for a couple of reasons. There's just more stuff going on up here, and then also all this stuff has to be connected to this stuff. Otherwise, when these pistons come up to the tippity top, they'll bump into the valves, these things right here, as they open up. You can see that there's not a whole lot of space here. And if they bump, they'll break, and then your engine doesn't work anymore until you take it apart and fix it. So how does all that stuff happen? Well, so here's a little video of this running. And we can see some things. So first off, there are these blue things in here, and every once in a while, they move. We'll focus in on this one right here. And we can see it just moved, and there's something rotating right in there. So what's rotating in there is this blue camshaft. It's called a camshaft because it has lobes. I have a camshaft right here. It also has lobes, and you can see when I rotate this that sometimes, if you just focus on one of these, like this one, when I rotate it, every once in a while, it's gonna bump into something because it sticks out, and the rest of the time, it doesn't. And it would just rotate in place. I'm not doing a very good job of this. It would just rotate in one spot like that, right? So every time one of these lobes comes around, and you can see that they're in different spots, the high points, every time one of these lobes comes around, it's going to move one of these valves in here, all right? So I'll plug this back in again, and we'll focus just on one. This one right here in the middle of the screen, right there, and it just went. It'll go one more time. Here we go. So what's that doing? Well, actually, what's causing that to move is a little rod that would push here, and this is the real one. So there'd be a rod that would push up. Oops, sorry. I'm looking at this. There'd be a rod that would push up on this, which would push down on this. And what's this connected to on the other end? One of these valves right here, all right? So, see, all those springs are over there. And that pushes one of these valves open. Now, where are the valves here? Well, I took this one apart, and the valves are here. So when we push here, can you see that the valve opens like that, right? And they open at different times to let air in and let exhaust out. And all that stuff is connected and synchronized in time by a timing belt right here, or on older cars, a timing chain, like the chain on a bicycle. And that's how it all works. So you have to synchronize all these moving parts. And when you get it just right, you get a machine that is able to burn fuel and turn it into reliable power output.